probably we might plan on object-oriented programming. That will take it up later on. Again, we'll talk about exception handling and regular expressions. All this step by step, and date time logging. There are other miscellaneous concepts as well, and then pandas. All this. So I just started recording. Please let me know if you can see my screen. Let me share my screen. Yeah. Can you see my screen? Just please confirm, friends, and then we can keep continuing. So yesterday we were talking about this, and then we are just discussing about built-in modules. So right? Generally, uh, we can break down modules into two types. One is custom modules, which we create. All these Python programs, what we create are custom modules. So apart from that, we do have built-in modules in Python. Something like math is a built-in one, and then random is a built-in one. So likewise, there are so many built-in modules. So there are thousands and thousands of built-in modules. And that is the power of Python, as we had discussed in the beginning of our discussion. Right? The strength of Python lies in its libraries. We have more than 1 lakh libraries in Python. So that itself is the power of Python, starting from the very old technologies to the latest new AI-related technologies. Python supports everything. That is the power of Python. So coming to the APIs, so we have lakhs of APIs in Python, built-in modules, and math. And just for discussion, we are taking math and random here. You can see here. So in this math module, you can see we are just trying to work with pi and power. Pi is a constant and power is a method. We're just trying to work with these two. And random is a method. Random is a module from where we can call random method. You can see here, random method generates random values, right? So that's the point here. And this round off that random value generated to 2 digits. When you say round method, round is used to round off some value with the number of digits you want here. We are rounding it to 2 digits after precision. So this is a quick idea, and this is simple to understand. We don't need to spend much time here. These are all built-in modules, and these will be useful sometimes when you are working in development. So that this is the quick idea about built-in or standard modules, and we just need to import that. We are applying from import for using these modules, math and random. From math module, we are importing all these members of that math module, that pi and power. And from random, we are trying to import. This is, you can see here, from import asterisk. One more third type of import we are discussing today is this one. What is it, friends? So we know we have regular imports. We have discussed different type of imports. One is regular imports, and second one from import. Okay, and third one from import. That too applying asterisk means everything. Of course, this is not recommended as per standard we follow. This from import asterisk, this is not recommended. So why? Because when you say asterisk, everything from this module random are imported to your symbol table. To which symbol table? To this current module symbol table. So again, performance wise, it is not good idea to apply import asterisk. This import is best thing or standard thing to choose for us, right? Import that specific members whichever you want to use. If you import that, that is always a standard or recommended standard, more than applying import asterisk. But just for discussion purpose, we are using this scenario. Okay. So you can see here, we are also applying one more import here. These are two types of imports. Import with specific modules, with specific members and import with asterisk. The difference is import with specific members allows us to import that specific to choose specific variables or methods or classes from a module. Import asterisk imports everything so that the symbol table of current module, this whatever the module wherever we are importing, that symbol table will be loaded with all these members when you apply import asterisk. And this is not recommended. I don't think we use this import asterisk quite often in development. That is not recommended. But just an FYI, if you ask me, is there any problem? There is no problem. Performance wise, we don't have big this thing with import asterisk. Advantage with import asterisk. But an idea. Now you can see we are just applying print pi directly as we applied from import and we are importing them. We can directly apply pi here. We can call pi and power functions. You can see 2 to the power of 3 we are trying. And also here you can see we are applying random function which generates random numbers from between 0 to 1. And that we are just trying to again round it. Now if you execute this program, let's execute this. See here. So these random numbers are generated between 0 to 1. In between that, it generates random numbers. So we can just modify it. If you want, you can change that. Got it, right? So by doing some calculations, you can change that values, whatever this random method is generating. Okay. This is just a quick idea about standard modules. So this is how we can play with standard modules. These are built in, and there are so many methods, so many variables inside this math. If you want, you can apply them from math module. Similarly, same thing. Random is also one more method, which is very frequently used in development. So just an FYI. So these are all standard modules. There are so many like OS, SysR, there are so many. Just to discuss that even we have built-in modules like this and we can use them. So we just took this example as a scenario. Thank you. So we do one thing then. This is about built-ins. Then we'll move to the next topic. What is the topic? Topic is about packages. What is the concept of package, right? And why do we need packages? That we discuss and complete this module topic now. So we can close all this. This is not that much needed. So now when we talk about packages here, modules, we did that. And one more quick check we can do is this one. Creating a driver program using main check. Okay, this is something main is already there in our Python programs. So once we are okay with built-in modules or predefined modules, so next thing we should understand is about this one. So sometimes we keep applying this in development, sometimes we don't. So if you ask me for our this thing, yeah, we directly create some main method and then we try to call it. We create some other kind of setup in our development. And this approach sometimes we see somewhere in some kind of code snippets. You got it right. So point is simple, friends. So this is like creating a driver program and validating if main method is present, then uh, it starts executing like a main program in C language, C++, something like that. Okay. So now how do you set this? Very simple. So this is, let us just take a simple scenario here. So what is that? Copy this code. If you want, you can copy the whole entire code as well. Right. So you can do one thing. Now you can go to the PyCharm and if okay, I choose already existing file, some test or something, just for testing purpose. And in this program, put even here also you can add main if you want. Otherwise, you do one thing. If you want to just add a driver program to this, by default this runs. So suppose you put a debugger somewhere, right? And then do one thing. Let's do one thing just for testing purpose. I'm showing you this. Put a call F1, okay? Or sorry, call M1 and put debugger here. Just to show you that main is already inbuilt in this program. Now you do one thing. Just try to debug this program. Let's that debugger start, and then I'll show you those. Yeah, debugging started, right? You see here these variables here. Under that, the special variables, you can see something here. You can see name equal to main. Given this, these are all part of the special variables. You got it right. If you want to explicitly define main as a driver program, implicitly this is there. If you want to define this, these are all special variables or magic variables. Okay, this you can see whichever you see with double underscore at the beginning and ending as prefix and suffix. These are all magic variables in Python. And this is there already. You can see that. So these are all specials created. Now, if you want to explicitly define a driver program by calling main, then that you have to specify it. What is that? If you have to just define this simple code snippet, if you add name, okay, underscore equal to, you can see here somewhere you can find that main here. Can you see that here? So this program, whatever it is assigned, is main. Right now, I want to explicitly define a driver program. This is the setup we can do that. So you can say main underscore. It should be under double underscore colon. Now this creates what is it, friends? A driver explicit way of calling main here, so that the execution starts from here. And then whatever you call under this block, if block, wherever you put this main check, this acts as a driver call. So now you can call M1, okay, and then you can call M2 of some 10, 20. So, right, all other things are very much familiar to you, friends. These variables, these methods. Okay, we just defined a dummy class here. This doesn't have anything, just we declared pass. If you want, you can create an object for that test as well. Something like saying some test equal to test. And if you want, you can print that test here. So that's fine. And you run this program now. You can see here. So M is called, and then of course we didn't print that. This M2 is returning something. You can directly print it if you want. Pass it to your print method, because M2 is returning some result. So now this time you can see the result from M2 as well, 30 here. Now this acts as a explicit way of defining a driver program. So this is one more useful scenario for us. You can see this kind of code in some places. Then one thing you should remember is we are explicitly defining driver here, so that the execution starts from this main, and then the calling starts with under that main. This makes much more organized way of executing a script. You got it right, friends? That is the idea. Understood now? So this is one more important thing apart from understanding standard modules. There are so many. I just only took two modules here. And then coming to this is how we can explicitly define a driver program, so that we can make this much more organized. So this is one more important thing we need. Sorry, friends. We need to understand. Got it? So that is the idea about this one. Maybe I can share this code snippet so that you can also test this. Let me share this with you. So next after that is maybe if you want, you can also take this simple example just for testing purpose, the standard modules. Let me share this also with you, just for quick testing. Later on, you can work with, there are so many built-ins, you can try with those as well. So let me share this as well. And then, okay. So that's all, friends. Somebody is asking question. I don't understand. How to pass work in test function? Work in test function. I didn't get that, Ashok. Maybe can you unmute and can you let me know what is that exactly?
You put in pass in the class test, right? So how does that work?
Oh, this one.
Yeah.
Yeah, yeah. See, this is just a filler, Ashok. Okay, when you
Hmm.
put pass here, if you don't want to add anything, but something should be there in your Python program, then we
Yeah.
that pass is like a filler. Do you get that, Ashok?
So,
Later on, whenever we see somewhere this pass means that is left for implementing in future. By looking at that, the developer understands. Okay, this is something left like that just for future development. You
got
got
it.
it, Ashok?
Yeah, I got it. Yeah.
It is
Thank
just a
you.
filler. So maybe didn't I discuss this sometime back in the basics like loops or something? Did we miss it?
Maybe I might have missed. Yeah.
Okay, if not, no, I am also checking because if you missed it, I'll cover it because I doubt continue, break, and pass. Did we cover that, friends? Can someone please let me know? Else, I'll just quickly recap on them as well, whichever is missing there. Okay, so these are even part of this control statements. So pass is something acts as a filler, Ashok. So if you don't have anything to add at present, at
Mm-hmm.
moment, in future
Got
if
it.
you want to implement it with something else. So best practice in Python is filling that with pass. And this acts as a filler, nothing more than that, Ashok. You got it?
Makes sense. Yes. Thank you.
Yes, that's it. Maybe if you want, you can define something. As we didn't yet discuss the concept of OOP, I just created a very simple class so that any one of us don't get confused. That is the only reason. Got it? Right. That's all,
Yes.
friends.
Yeah.
This is the idea. Anyhow, you come to know about if so that continue, break, and pass. Those were again three important keywords we need to discuss. Let me know if we had discussed that. If anything is there, we can quickly recap. We can spend quick minutes and then cover that. Okay. So this is idea about this one. And finally, packages, modules and packages. Concept is same. The kind of import or from import, all that. Almost to have a similarity. Only difference is package is a bigger one. That's at folder level. Module is at program level or script level. Okay, so these are all built-ins. There are so many built-in methods here with math. We just tested few of them. If you want, you can try all this as well. And then after that, random we just quickly discussed. If you want, you can give try with this as well. And this is about packages. What is a package? Package again, sometimes in development, we need to work with modules in some scenarios, and also we need to import packages as well. Both will be there. Okay. So what is package now? Package is simple collection of modules. Simply speaking, if you just want to get a quick idea, all these are packages. What is there in each of these? Nothing simple, right? If you just expand anything, you just have some Python files inside that. And by now we know that any Python program with .py extension is a module. And package is simply speaking collection of modules. That's all. And if you want to use these modules in some other module package, then we have to again go with this import or this what is it, friends, from import, all that. So that is the quick idea. Again, concept of package is almost similar to module only. What is that? Why we need packages? It is collection of modules. So here you can see here collection of functions or modules or packages whatever it is, all these are used to modularize code. If you want to break down program into parts and modularize it, then this concept of functions or modules, packages, classes, enumerations, all these are a way of modularizing code which enhances readability of programming. Another advantage is these are all reusable components. And third thing is with the advantage of with the concept of packages, we can avoid naming conflict. Suppose you want same module name defined two times with different functionality. That is not possible to define in the same package. Suppose I defined a.py in this in this package modules, I cannot have another file a.py in the same package. That is redeclaration, duplication. But what I can do, I can create another package and I can create a module with same name in that package. We can have multiple modules in different packages with same names. So in that way, what is the advantage we have? The advantage we have here is it avoids naming conflict. So that avoids what, friends? It avoids naming conflict. So that is the advantage. Okay, one important thing about packages. So if you see this init.py, so this underscore unit, even now, of course, until Python 3.3 version, this is mandatory. In latest versions, it is saying that it is not mandatory, but still, it's always a good practice to keep this init.py under any Python package. You can see here. Suppose if I expand any of this, you can have init.py. Maybe if you ask me a question, what is there inside that? Nothing will be there inside that. But as a standard practice, this empty init.py that we have to keep inside this package, Python package. That differentiate Python package from normal folders. In a simple discussion, package is nothing but a folder where we keep all these programs, Python programs, exclusively Python programs. Means .py files. One important thing is having this .py file, init.py file is a standard practice. Got it, right? Even now, people follow that. Even it's not mandatory in the latest versions. Still, developers follow that practice. It's a standard practice. Got it, right, friends? So that is one more important thing. So what is this init.py? As a standard practice, we keep that in the inside a package. Got it, right, friends? But it is optional. Next, after that, let's talk about. Let's get into the discussion here. How to work with packages, same as how we work with modules. Now we work with packages in the same way how we did with modules. We use normal import from import, using importing specific modules from import asterisk, import asterisk. Mostly this is almost not recommended. Last third approach. So that's all, friends. First two approaches are most used approaches. Normal import and from import, choosing specific members. Okay, that is fine. These are the syntaxes again. Import that package name dot module name. Whenever see in development, you see something like abc dot xyz dot something, then definitely it's a package. Just a quick tip for you. You got it right, friends. abc dot xyz dot some member. If you see two dots, more than two dots, then we are trying to get something from a package. Got it right? So this is syntax. Import package name dot module name. And that is not enough again. Again, what is that you should do? Again, you should say package name dot module name dot. You can see the example. Got it right? So something like that. Similarly, package name dot module name. You can import how many other packages you want. Generally, this single import is not recommended in development. So I imported one package here. Suppose I want to import another module from same package. I apply one more import in development like this. This is the standard approach. we follow in development. More than saying comma separated and then importing all modules in one package, we generally don't do this in development. We can do that. There is nothing harm in that. But as a standard practice, we try to import like this. Import package name dot module 2. Again, from the same package, if you want to import another module, package name dot module 3, something like this. Right. So we can create multiple modules from same package like this. Suppose if you want another package, then you can take something like this. Package name 2 dot module 1. Okay, something. And this keeps going. You can import how many more packages you want, how many more modules you want. It's up to you. Sometimes we try to import this members, these variables, methods, and classes from packages. Of course, at the end, it will be from module. Even if it is a package is collection of modules. You have to get this members. Members means these variables or methods or classes from module at the end. But if you should get something from module, either we can get it from module directly in some cases. In some cases, it has to come from packages. So in such cases, what is that? We can directly choose to import module if it is directly available in the current scenario. Else we have to use that package dot module name. Whichever you think is required in that case, we choose that. But we already know about all approaches now. So this is the idea, friends. The standard is this, and the syntax wise, we can just have this, that package dot module, all that stuff. Okay, comma separated is fine, but that is only at learning level. And development level, this is what we always follow. That too, don't import unwanted, don't apply unwanted imports. Suppose you import some package or module you are not using, then it is not recommended. Just an FYI. Next, after that, another important thing is whenever you are importing a package and a module together, aliasing is something we always do in Python. What is that? Aliasing. Suppose I say all this as M1, as M2, as M3, something like this. As again, something like PM1, something, just to make sure alias is not duplicated. So this aliasing is something even we follow as a standard practice in Python for these modules. I will just make the name short. Instead of having lengthy names while calling, we just make it short with aliases. That too, we provide meaningful aliases. We don't provide just like as A, as B, as C in development. Here, just for learning purpose, we are just having some quick, simple names. In development, we provide meaningful names so that developer don't get confused, or developer doesn't need to go back again and see what is this alias. So just these are all important things just to understand. Other things are same. The way we import and from import, all these are whatever we discussed with modules, we can apply with packages with a little bit of adding package thing here. Okay, we'll do one thing. We'll just try to implement few examples. Okay. So let's do one thing. If we finish this, we are almost done with that. Even we can have a concept of sub packages. If we have sub package, then package 1 dot, package 2 dot, that module dot, that member name. That's all. As the level of folders increases, that dot scenario increases. Suppose you have sub package, something like you have pack 1, inside that you have pack 2, inside that you have pack 3. Okay, inside that now you have something. So the depth of this folder is what we have, a depth of 3. Then expect 4 dots here. What is that? To call something from pack 3, how to say pack 1 dot, pack 2 dot, pack 3 dot, some module name dot, that member name. Okay, something like this. So this is how we can also work with sub packages. And concept of import and from import, all this is same again. But the way you need to call these members from sub modules, sorry, sub packages. This is how we do that. As the depth increases, number of dots increases here. That package 1 dot, package 2 dot, package 3 dot. That at module level, you have to say module name dot and then member name. To avoid all this, what we do is at module level, we put some alias here, something like m or something, and then we call m dot some member 1, okay, something like this, m dot some member 2, something like that, if it is a normal import. Okay, this is fine, friends. Let's do a quick check on this. We'll just quick testing and then jump to the next topic. Okay, what do we do now? There are so many modules here. So we just need simple modules. We don't need too much of this thing. Suppose you see here, I'll do one thing. So where is this modules? And then these are all simple modules, not packages. We try to import something here. We do one thing. Let's take this example itself, test itself for testing other modules. So what we do is we remove all this because this is a test one. Already I shared that code with you. So even if I made changes, so assume this is a fresh file. So what I do is now I want to use some examples. Suppose you take dict here. Yeah, this is a very simple example. Probably we don't have too many here. So we do one thing. I want to use these dictionaries from dict introduction module, which is there in dict class under dict class package. I want to import here. Then what is that I should do? Import. So that package name dot dict class, you can see there dot. When I say dot, you can see it shows you all different modules present in that package. You can see here. Now I just want dict introduction. Okay. So this is module. As you can say some just DI. Dict introduction is DI. This is how we import packages in development. That alias name would be something meaningful like that. DI says dict introduction. Now what I do, I simply say printf. I'm directly using it. I'm printing. In development, we don't print. We try to get that data from those methods or variables or classes and do something else. But here just for testing, I say di dot. Okay, I'm printing this fruit dict. Similarly, there are so many things in this. You can see here, right? And that dict introduction is not there inside this modules. Here we are calling this dict introduction from modules package. But dict introduction is present in which package? It is present in under dict class. You can see here. So both are two different packages. If a module is from different package, we have to make sure that we import that package name first and then that module name. If you have more depth in that package, means subfolders. If we have a subfolder level, then we should say that that pack 1 dot pack 2 dot something. That's how you have to just keep adding that imports. Got it right, friends? Then again, dict introduction has this fruits dict and then movie. We can call movie dict as well, just for testing. Print, we can say di dot. So you can just directly choose di dot movie dict. Just for testing, this is enough for us. This is how we can import a package and a module together, or a module from a package, and then we can call members from that module. At the end, it is at module. We have to call everything from module only, because inside that Python program, we have all this. We have these variables, we have this methods, we have these classes, everything. But to go to that level, first we should import that package as well. That is important. Okay, now what do you do? Just run this program. Now you can see that we are able to get that dictionaries from where? From dict introduction. But we are calling from test.py, which is under what? Which is under modules package. This test.py is a Python program which is totally from a different module, different package. And dict.introduction is from a different package. But we are able to import it successfully by applying this regular imports here. Similarly, you can apply from import as well. Suppose you can take another scenario, right? From that, again, what is that you should do in this case? You can do one thing. Simply you copy this package name dot module name, same thing again as, sorry, from package name dot module name import. What is that we should choose now? There are so many things in dict here. What you want to import? This time we directly import, right? Fruit dict, movie dict, something like that. So you do one thing. You can see it's when I just say F, automatically it is showing that members from that module. Which module? Dict introduction. Fruits dict as FD. Just comma. Again, something like I say movie dict as MD, right? And now what I do, just for testing, I am showing you all that. You don't need two approaches when you are following this. Either you can use regular import or from import. Whichever you think is best fit for you, you can choose that. But I am showing you both approaches so that we get that idea. Later on, you choose which works best for you. My recommendation is from import here. Got it right? So now copy these two. This time we don't need to say, if you are using from import, we don't need to say module name dot that member name. Whatever it is, it might be variable, method, or a class, function, or a class, or whatever it is, or something from class, or a enumerator, whatever it is. So here we can say FD. Okay, and then here also, what is it? MD. We are doing same operation, but one approach is regular import. Second approach is from import. That's all. That's all, friends. And we can easily see the difference here between both. Also, which is best recommended, we have already discussed that. Performance wise, which is best here? Obviously, from import gives better performance than regular imports. But in development, we prefer both. Just an FYI. Okay. So next, run this now. We see four this thing here. We got four outputs. That is pretty well working. So this is the idea about what is that? How to import packages. Importing packages is again simple, friends. We import module from package. That's all. Got it right? Importing just package is not helpful. We have to get members from the module. That is the idea. Got it right, friends? So this is all idea about all different scenarios in packages. I mean this module topic. What is module? How to import them? Different types of imports. What is package? How to import them? All that. And one more is again, see this one. Last scenario. From import asterisk scenario. So this is not recommended, just only for quick discussion. We are covering that here as a part of covering this scenario as well. We are discussing, and this is not recommended. What is this? This is not recommended, right? Or avoid this approach. Avoid this approach as much as possible. Got it right? As much as possible. Just an FYI, friends. Okay, because this is not a recommended one. And we can use imports wherever you want. It's not like every time you have to put at the beginning of program. In Python, it is very flexible. You can use imports within a method itself, right? Or within a method within a method inside a class. You think wherever you think it is needed, you can instantly apply this. But in most of the cases, we keep at the beginning of program so that they can be globally used in the script. So that is the idea. Same thing, if you want, you can directly do one thing, copy this. When we say that here, there are so many things inside this, right? From import asterisk means we try to call something which we are not calling. Let's apply dict1 is empty, dict2, dict3. Do one thing, call dict2, dict1, okay, dict2. Just for testing, that is enough, friends. Applying asterisk. When you say apply asterisk, you can see that all members are available for this program. Which program? For this module, test.py. Now run this now. Now you can see dict1 and dict2 are empty dictionaries, so we are not seeing anything. Probably, see, yeah, these are all empty here. Maybe dict3 has some data. If you want, you can call that. So this is how we have to play around while working with modules. Maybe you can put dict3. So you can see that it has some data. We got that here. So this is the idea about what is that, friends, working with all different scenarios of modules. So we are done with modules. We have to jump to another very useful topic, that is OOP. So I thought to go with another topic, but OOP is much more higher priority topic. So first let's cover that. We try to cover everything. It's not like we miss on anything. Then we come to regular expressions, exception handling, all that, logging, playing with dates and time, everything. So tomorrow, when we get into anything, then definitely all this, whatever that is need for development, when you look at that, that we should cover. That's what the idea is, friends. So next after that is next topic. We have to get into the another very interesting one. So that topic is classes and objects. I'll just give an intro today. Maybe from Monday we make it much more. We take it on full on. Whatever time we have, in that time I give you intro, friends. Okay. So now what is OOP? So with this we are done with modules. I don't think we have much to discuss on modules topic. Whatever that is needed, we covered as from development perspective. If you want, you can create sub packages and test one scenario like this. That would be finally completing that. Okay. So now, so next thing we are going to talk today is we are jumping to the another the most useful topic in Python is what is it, friends? OOP. Let's talk it. I just take a quick introduction. Let's not waste much time today. So, so let's talk about it. Object oriented programming. Okay, in brackets we can say object oriented programming. But generally people have the habit of saying oops, OOP, oops. But technically that concept oops is not there. But in flow people keep saying that. Okay. So we have OOP, object oriented programming. That S is just added by us only. But there is no that specific this thing abbreviation for S. Okay. But what we have is what, friends? Object oriented programming. That's all. So, and this is something not specific to Python. Whatever we covered so far, it is not just something applicable only in Python. Many of these, if you are really familiar with whatever we have discussed, you can also work out with in even the same thing in Java or C sharp or any other language, because syntactically there will be almost these languages are similar, and OOP is even same. OOP is a concept of it's nothing but object oriented programming is the principles we apply for programming. Okay, and there are many object oriented programming languages, not just Python. Probably C++ is the first OOP language, I believe, or before C++, there is Smalltalk, Simula, 67. There are many, friends. It came from there. Okay. So now, after that, Python definitely. Then came Java, then came C sharp. Like that, this evolution happened. Then came all this latest technologies like, Kotlin, and then there are so many, even mobile-based languages, there are so many. But any OOP, sorry friends, any object-oriented programming, they have some principles. If those principles are applied to any language, then it is OOP. So what is that? Object-oriented means it should have first thing object. We'll talk about everything in detail. Definitely, if you have any confusion or if you are little feeling this is a little complex or difficult one, these sessions definitely make you feel that these are very interesting and simple. Because whatever background is needed, we already have that right now with core, that functional programming. So far, whatever we have discussed is functional Python. Even Python has differentiation, right? We have functional Python, whatever we discussed so far, without any classes and objects. This is object-oriented Python, right? So that is the advantage of Python. We have multi-paradigm support, and this is one approach. So what are those concepts of OOP here now? Let's talk that and we'll see the differences there. First, we should understand what exactly is object, then what is class, then what is abstraction, okay? And then what is encapsulation, okay? And then inheritance, and then polymorphism. These are very important principles of or concepts of OOP, right? You get this right, friends. So now, any OOP language, any object-oriented programming language has these features. There is one more division called object-based, like JavaScript, VB script shells. There are certain kind of scripting languages, not Python. Python is a complete object oriented. There are object based languages. They just have objects and classes. I believe they don't have this concept of polymorphism or inheritance. Something is missing there. You can check it out, friends, in Google. Object oriented versus object based. But in both of these languages, categories, common thing is objects and classes. For anything, the core thing is objects and classes. If you understand the concept of objects and classes, the rest of the things are nothing. They are just concepts which are enhanced on top of this object and class. You got it right, friends? So our main goal should be understanding what is object, what is class. Okay, now let's start with object. Object means what? Simple, friends. In general terminology, it is a real world entity. Most of you know that. Objects are real world entities. Okay, that is quick thing. Next one. Second one is what is that? When it is a real world entity, something like name, person, or anything, there whatever you see and whatever you can touch in real world is object. So that's what object is. Something like not name, sorry, something like person, place, thing. Okay, person, place, thing, everything. All these are objects. Sorry, friends. etc. That is an object. And technically, when we talk with programming, when we say what is an object is an instance of a class. Okay, instance of a class. Next after that is the idea. Maybe if you ask me what is instance, I'll talk about it. Instance, just for quick meaning, it is memory. Instance means memory. Memory of a class. What is that memory? How it is at memory level, how it is represented at memory level, how to create objects, that we have a very detailed discussion. Okay, but this is the idea, friends. So object is an instance or memory of a class. So means what? Point is simple. It allocates memory for a class. So another simple point is what object does is object allocates. Whenever object is created, it allocates a memory for a class. If you ask me again how it happens, I will show you a detailed demonstration. Like, we'll do a tracing of every step. Once we create class and object program, we try to do the postmortem on that so that you get a very clear picture about everything. We do the dissection of classes and objects so that we get that complete memory level idea, not just at program level. We get memory level so that it's easy for you in future to apply your this thing. So that is object here. Got it, right? And one important thing when we talk about object, what is that object have here? Object have attributes, okay, or properties. So whenever we talk any about any object, it has properties, it has actions. Okay, actions means we'll talk about that. Attributes means something like any object you take. So how do we identify object? Those are attributes. Something like you take example, any example of real world. Let's take the example of person itself. Okay, let's take from here. Person has attributes like what? Like name, age, okay, height, something like this. We can add how many ever we want, age, color, okay, color, all this. So these are all attributes. Similarly, if you take car has name again, and then color, and then number, and then price. Those are attributes of car, right? Similarly, like that, for every object has attributes and actions. Actions, generally attributes are represented with properties, or attributes or properties are represented with the variables in a program. How do we represent them? Variables in a program. Okay. And actions means actions are nothing but methods. So what are actions of person? Person actions are simple, friends. So reading, something like reading, writing, okay, sleeping, all these are actions. Dot, dot, dot. Generally, these kind of actions, any activity, we represent with what is that here? Actions are represented with methods in a program. How do we represent? We represent with methods or functions. The other name for this methods is functions or methods. Okay, in a program or in a Python program, any program, even in OOP or anything, even in Java or C Sharp or any language. So this is the idea. First, we should understand these things, friends. First, you should know what is object. So difference between our program object and real world objects, and how do we simulate that in code? Simulation happens with by taking the real world things and we programize it. How do we programize it? By taking those attributes of real world and declaring them as variables. How do we again add methods? By taking actions of real world object and programmatically we represent with methods or functions. Right? Don't get confused. You can these are synonyms. That's all. Functions or methods. You can use interchangeably. No problem. Okay. This is the idea, friends. Next, after that, you got it right. So this is programmatic approach of representing real world things. And examples we have seen here. These are all examples. But one important thing you should observe is if you want to do something in program, if you want to work with object, we cannot directly create objects. What is it? We can't directly create objects. Before that, as definition itself is saying what is a object here means we are saying instance of class or it allocates memory for a class. Means what? If object should allocate memory for class, before that what must exist? A class must exist. So in OP, order of creating these entities should be like this. First, we should define class. What should be there? We have to have class and then we create object. And then we call members of that class. Okay. Calling members is something like we already discussed, like calling methods, like calling variables. We already did that in regular Python scripts as well. But here we go with a little bit of more wrappered approach. We add a wrapper and then from that wrapper we call things. Same thing what we did in functional programming. But what we do in OOP, to that functional programming, we provide one wrapper and we call something from that wrapper. That is nothing but class. Got it right? So that is the, simply speaking, whatever we did in functional programming, same thing, almost similar thing we do here. But with what? With a kind of a wrappered approach. That wrapper is nothing but class and object. So this is the step. Now, once we get this quick idea, then we should understand about class. What is a class? So general definition of classes, we already know this. Blueprint, people sometimes people call blueprint. Okay, or plan of object. Okay, we call with many simple generalized names. But in real life, but in programming terminologies, class is collection of what is that? What, just simply speaking, I'll just make it as a formula. It has variables plus methods inside that. Simply, if you just create a simple formula approach, what can be there inside class? It can have variables plus methods. And if you ask me, is it mandatory to have variables and methods both together? It's not mandatory. You can have only variables. We can have only methods. Sometimes we can have empty classes. Just sometime back, Ashok asked me, right? What is that pass Manoram? You can just define empty classes as well. It's up to us. Okay. So means what? What can be there inside class? Technically speaking, it can have it not it should it can have variables or methods or both or nothing. You have four different possibilities. Got it right? But in reality, when you do real development, definitely class has variables and methods. Then why do we create OOP programming, right? Definitely we need some requirement. We have some requirement to implement that. We need whatever it is needed. We do that inside classes. Sometimes we might define only set of methods. Sometimes we define variables and methods. Everything, something like that. So this is again this way. There are types of variables, types of methods, instance variables, static variables. Okay, again, instance methods, static methods, all that again we'll discuss in the next coming session. At least this introduction takes some 2 to 3 sessions or 3 or 4 sessions to give you a complete overall, a big picture about everything. But this is very interesting thing compared to whatever we have discussed so far. So this is the idea. Class is collection of what? Variables, methods. Okay. Or it can be collection of only variables, or it can be collection of only methods. Okay. Both are optional. Or collection of variables and methods. Sometimes you can have nothing also. You can create a class, empty class as well. We'll see all this step by step. Okay. But technically we put both variables and methods in development. This is the idea and introduction to OOP, object oriented programming. What is object class? How we derive the concept of object from real world entities, all this, how we derive class concept from existing objects, from real world objects, all that we see with examples in the next session, friends, in the upcoming session. So that's all for today. Uh, hope you have got a clear intro for class and object, but we'll have much more deeper this thing with that we'll discuss that in the coming sessions. Thank you. Happy weekend because tomorrow and after we have what is it? Weekend, right? Yeah. We'll catch up again on Monday, friends. Let me stop this.